Today's industrial controls and automation cabinets are challenged by higher density, higher power electronics. The increased electrical component densities permit more control, measurement, and monitoring in smaller and smaller enclosures. Higher component density is typically associated with higher internal enclosure heat loads. Adding to the heat load challenge are applications that require the cabinet to remain sealed from a variety of external contaminants, such as dust and aerosolized or sprayed or suspended chemicals. Additionally, some applications require frequent use of corrosive washdown, spray-down cleaning agents that can damage the outside and inside enclosure contents. Typically, fan coolers are incapable of keeping unwanted contaminants out of controlled cabinets because two cutouts, made for intake and exhaust air, are required. It's easy to visualize the damage caused by corrosive chemicals such as chlorine, ammonia, or hydrogen peroxide cleaning agents that may collect or even come in contact with the inside or outside of the unsealed enclosure. Structural damage and component failure can occur. That's for indoor applications. Outdoor applications present their own challenges. Enclosures and their internal components can be damaged by salt spray, agricultural dust, and molds that can electrically bridge circuits and cause systemic electrical failure. Fortunately, advanced cooling technologies provide seal enclosure coolers that effectively protect sealed cabinets from external contaminants and moisture. ACT's line of heatsink and heat pipe-based coolers are sometimes referred to as heat exchangers. ACT's sealed enclosure cooling heat exchangers offer excellent thermal management for sealed enclosures where the air temperature on the inside of the enclosure is hotter than the air outside the cabinet. These applications are referred to as above ambient cooling. The reverse case, where the air temperature is hotter on the outside of the cabinet, requires subambient or active cooling. ACT offers thermoelectric solid-state air conditioning systems to meet this need. ACT features two products for above ambient passive sealed enclosure cooling. They essentially differ in heat transfer technology, mounting size, orientation, panel depth, and heat load dissipation capacity. Depending upon the application, heat exchangers are a great choice over air conditioner enclosure cooling. They are cost-effective to operate and have minimal maintenance requirements. In contrast, a vapor compression-based air conditioner has many potential points of failure. Refrigerant can run low or leak. Filters that are not maintained can cause the compressor to run hot and eventually fail. An air conditioner can be a power load, and the heat generated from the condenser is commonly discharged into the work environment, making conditions uncomfortably warm and noisy for the people working near the unit. ACT heat exchangers are a better choice over vapor compression cooling due to their inherent reliability and low operational costs. ACT heat exchangers are a viable option, even with as little as a 5 to 10 degree temperature delta between the inside and outside of the enclosure. However, the larger the temperature gradient, the better the overall cooling capacity. The ACT HSC heatsink cooler is an air-to-air heat exchanger that efficiently removes heat from a sealed enclosure by simply transferring heat from a bonded heatsink on the inside of the cabinet through a sealed wall to a common bonded heatsink outside of the cabinet. Integrated inner and outer cabinet circulating fans blow over the surface of the fins, enhancing the heat transfer. In contrast, fan filter systems cool the cabinet by drawing in potentially contaminated external air and circulating it throughout the inside of the enclosure. ACT's HSC series of enclosure coolers are based on a patent-pending design that utilizes an air impingement technology that is thermally efficient and enhanced by thermal bonded finned heat sink components. As a result, The ACT HSC series offers some of the best performance-cost ratios among all sealed enclosure cooling technologies. They can cool enclosures with heat loads starting at 440 watts to 1360 watts. The ACT HSC is an excellent choice for high component density cabinets. An installed ACT HSC cooler only protrudes into the cabinet by 3.7 inches. The units are completely touch-safe and feature easy mounting and installation. The dual ball bearing fans feature very long life at over 5 years of continuous operation. The ACT HPC heat pipe cooler series is based on our highly reliable heat pipe heat exchanger technology and incorporates advanced fin features for enhanced heat transfer performance. As a result, the HPC series offers some of the best performance volume and performance cost ratios among similar industry products. Since the ACT HPC series are thermosiphon and gravity-aided heat transfer devices, they favor being mounted on the top of the cabinet. The lower half of the sealed ACT HPC heat pipe heat exchanger is on the inside of the cabinet. There, the heat pipe's heat transfer working fluid evaporates in the hotter inner cabinet environment. The internal heat pipe vapor flows through a sealed dividing plate to the outer part of the cabinet housed by the ACT HPC, then condenses and flows back to the inside of the cabinet as a liquid, aided by gravity. The ACT HPC does require more depth on the inside of the cabinet, starting at 5.6 inches of protrusion. A good installation rule of thumb is that there should be about 6 inches of clearance all around the heat exchanger. Special care should be made not to block the airflow with internal enclosure components. The ACT HPC sealed heat exchangers are capable of addressing cabinet heat loads starting at 300 watts to 1600 watts. Applications with higher heat loads can be handled by installing 2 or more enclosure coolers if room permits. Our above ambient enclosure coolers keep your cabinet dry and contaminant-free, whether your application is designed for a NEMA 12, 3R, 4, or NEMA 4X corrosion-rated environment. The operating voltage ranges are from 12, 24, and 48 VDC to 115 or 230 VAC. For applications that are subambient, where the inside enclosure temperature is cooler than the exterior temperature, an ACT TEC, thermoelectric air conditioner, can be applied. ACT TECs are available to address internal enclosure heat loads of 90 watts or 300 BTUs per hour, and 300 watts or 1000 BTUs per hour. Our thermoelectric cooler incorporates Peltier electronics to convert the incoming voltage to cool the enclosure. A major advantage is that there is no compressor or refrigerant needed to perform the cooling function. Precise temperature control and internal cabinet humidity control are additional applied advantages. The ACT TECs are available in 24 VDC, 115 to 230 VAC control voltages, and can address applications for NEMA 12, 3R, 4, and 4X installations. To make the application and selection process easy, ACT offers an online selection tool that provides a product selection based on your application parameters of panel size, mounting preference, operating temperatures, and heat loads. A simple click of the Calculate Selection tab provides choices closest to your application criteria. The user can then choose by product size and price. A printout of the selection is also possible, as well as requesting direct application support from ACT. By clicking on one of the selection tool results, you are directed to ACT's web store for final configuration parameters of voltage range and NEMA value. From there, A price is calculated and an order can be placed. You are welcome to call in your order or request application assistance throughout the application and selection process. To try out our selection tool, get budgetary pricing, technical documents, or technical assistance, visit www.1-act.com/enclosure-cooling. Thank you.